Okay, let us continue with the Schmitt Trigger experiment. So, in the last video, we have discussed the op amp as a comparator and its improvisation as a Schmitt Trigger. So, we are just continuing with the same Schmitt Trigger, which is an inverting Schmitt Trigger. And we are introducing one reference voltage we reference here and trying to understand what is the impact of this reference voltage on the circuit operation. Okay, this is the V reference that I applied. So without this V reference, we know that the upper threshold voltage or higher threshold voltage is given by plus Vsat multiplied by R2 by R plus R2, and VTL lower threshold voltage is given by minus Vsat R2 by R plus R2. It is without this. When I add this one, so there is another voltage being added to both the upper and lower threshold voltages, which is due to this V reference, and whenever this is a V reference voltage, then this becomes R1 divided by R1 plus R2. This is now R1 by R1 plus R2. So the voltage at this point is now due to two sources. One is this and other is this. The voltage due to first source at non-inverting terminal V plus is, okay, this is V naught multiplied by R2 by R1 plus R2, which is this potential divider, taking this as the voltage source and grounding this. So this is what we do in superposition theorem. If you want to find voltage at any node, when both the voltages are there, you consider one voltage at a time. So this is that partial voltage at the non-inverting terminal when you consider V naught, and when you consider this and not considering this, when I make this V naught as 0, when I consider this, the voltage at this point is V reference multiplied by R1 divided by R1 plus R2, which is the second term. So the voltage at V plus, when this is plus Vsat, has got two terms. One is due to this plus Vsat and that is due to this V reference. Similarly, when this output voltage is at minus Vsat, I will have the voltage due to this V naught as minus Vsat into R2 by R plus R2. Due to this, it's again the addition, which is V reference R1 by R1 plus R2. So this extra voltage will be added to both higher threshold and lower threshold voltage whenever we consider this V reference in the circuit. So in the analog discovery, I'll be connecting the input voltage to first channel, and I want to observe the waveform in the scope channel 1 of the scope. Channel 2 of the scope will indicate me the output waveform, and the required reference voltage is obtained from the second channel of the wave channel. Of course, we have this as 4.28 and this as minus 2.8. We are using one DRB, and there is a resistor R2 which is always kept as 33 kilo ohm. So keeping this as 33k and taking plus Vsat as 4.28 and minus 2.8 as minus Vsat, for these values of R1 and V reference, we are, of course, I calculated this VTH comes out to be 3.68 volt. It is after using those values of R1, R2 and V reference and Vsat. So I will get plus VTH as 3.68 volt, meaning if the input voltage crosses 3.68, output makes a transition from plus Vsat to minus Vsat, and VTL is minus 1.67. So when the input voltage tries to go below this minus 1.67, output will make a transition from minus Vsat to plus Vsat. So let me set these values. Okay, I'm using this is my variable resistor, this is my DRB. So DRB value I kept it at 10k. The fixed resistor is 33k. So let me see what is my okay, this is my wave gen. So here I'm applying through channel 1, I'm applying a sine wave of 5 volt amplitude. This is sine 2 pi 100t. So this is the waveform that I'm applying at the inverting terminal, which is amplitude 5, a frequency of 100 Hertz, which is 5 sine 2 pi 100t. And the input voltage, the reference voltage I'm applying at using another channel is actually 2 volts. So this is as per my tabular column. So this is 10K, V reference is 2 volt. I should get VTH as 3.68 and VTLS minus 1.67. Let us see what is the values. Okay, this is my input voltage, this is my offset, that is V reference. Let me see what is the output. That this is my scope. Let me run the scope. Okay, I'm just set my cursor 1 for VTL. This is my second cursor for VTH. If I stop it, let me do one shot. You can see now this is I have to measure at the input what is the transition point, at to which point it makes a transition. Now practically I'm getting VTLS minus 1.51. This is my practical value of VTL minus 1.51, and practical value of VTH is 3.74, 3.73 or 3.74. So this is my readings. So I was supposed to get 3.68, I'm getting 3.73. I was supposed to get minus 1.67, I'm getting minus 1.51. So let me adjust this to minus 3 volt, the reference voltage, and try to see what are doing. You can see now. So this is that VTL, this is VTH. VTH is coming out to be, you can see here, this is 1, 2, 3, almost 3.6 or 7, which is this 3.7. You can see now this is 1, this is minus 1, minus 2, it's around minus 1.5. This is minus 1.5. So let me adjust the offset to this. My reference voltage is now minus 3 as per my one of the value that I've calculated. So this is the value that I've assumed, it is minus 3 now. So for minus 3, if I run it, what I'll get, so I have to get VTH, VTL as VTH, VTL expected is 2.53 and minus 2.8. So let me run this and then adjust the VTH, VTL. You can see it has changed. Let me adjust this to this transition. This is VTL, this is VTH, this is VTH. You can see I'm getting, let me stop this, let me take a single run. This is actually VTL. So this is cursor 1, cursor 1 is this is VTL, which is minus 2.6. so this is minus 2.68 and this is plus 2.53. See here, these are my practical values. Because I already calculated the theoretical values, it's just I don't want to I'm just saving time here. So I have already calculated a threshold, lower threshold and higher threshold voltage using these equations for the values of V reference and R1, R2 and V sat. So I was supposed to get 2.53, I'm getting almost close to it. The VTL is supposed to be minus 2.83, minus 2.8, I'm getting minus 2.68. Okay, let me adjust this R1 DRV value to 68K and have different reference. Now it is 10, 20, 30, 40, 50, 60. 1, 2, 3, 4, 5, 6, 7, 8, 68K. I'm already having a reference of 3 volts here. So, okay, if I run it now, I have to get a threshold voltage VTH as 3.38 and VTLS. Okay, both are positive here. You can see this is what is interesting to see. So both threshold voltages are positive. So let me just run here. It should be positive, no? I think it's actually negative. So let me make it positive. Now let me go to scope and then run this. So let me set this. This is actually VTL low to high transition. This is actually VTH, which is high to low transition. Can you see this is cursor 2 corresponds to the VTH, which is 3.4. Now it is 3.4 plus what is VTL. Interestingly, you can see VTL is also positive. VTL is also, it's almost there. So it's 1.1. It is plus 1.1. So if you see your calculations, The calculation wise also you're supposed to get both are positive. You can see it is 3.38 expected, you're getting 3.4. You expected 1.09, you're getting 1.1. So both are positive. Interesting thing is that using this reference voltage you can able to make the transition points moving both onto the positive sides. Now both positive and VTH and VTL are become positive. If you see here, can you see this is 0, so the transitions are happening both on the positive side. If the input voltage goes beyond 3.4, it is making a transition from plus V side to minus V side. If input tries to go less than 1.1, output is going from minus to plus V side. So this is possible only using this reference voltage. Since we have used a larger reference voltage, now this has started moving. Now let me apply to the same setting values of R1, R2. Let me apply a negative reference voltage, which we have calculated here as one of the readings. You can see now it is minus 3. So it will result in both negative voltages. So VTH is also negative, VTL is also negative. So it is possible only with insertion of a reference voltage. If you don't have reference voltage, it is difficult to get both threshold voltages moving on to both positive side and negative side. So now let me move this here. Okay, this is usually, of course, we are using second cursor for VTH. Let me use the first cursor for VTL. So now this is VTL. You can see now VTL is minus 2.8. This is minus 2.83 and it is minus 0.65. Let me just make a single shot to minus 0.67. So these are my practical values. You can see now this is my theoretical value minus 0.63. I'm getting almost minus 0.67. This was supposed to be minus 2.92. I'm getting almost close to that. So now here both VTH and VTL are negative. So we can see in the above two cases, one is positive, one is negative, and in these cases both the voltages are positive, both threshold voltages are negative. It's possible only with, you can see now it has become less than 0. So let me just run here and then show you how it will happen. So let me just take this out and let me vary this reference voltage to you and then see how does the cursor moves or the hysteresis moves. Sorry, this was not. Let me move this down here. Let me put this also down. Let me take out this cursor and let me make this a basic one. Let me use a DC voltage. Now if I just change this, you can see now, let me keep running. See now this is with without any reference voltage. I have almost plus V sat minus V sat here. Sorry, the VTH VTL are, one is negative, one is positive. If you maybe let me just expand this. This is more interesting to see. This, okay, let me take this. See now this is, let me, suppose when I just increasing this reference voltage, you can see the both are becoming positive. Now this is your 0 point, this is your 0 point, both have gone to positive side because I applied a larger positive voltage, positive reference voltage. You can see it's keep moving, and if you make this reference voltage negative, both will become negative. You can see now both are moving, so they actually came here and both are negative now. Interesting thing to note here is the reference voltage will actually move the threshold voltage both to positive, both negative. It can be positive negative also. So that's how it changes. And suppose if I keep the very important thing, what we have to note here is it's really important. Now input voltage we have kept it 5 volt. The input voltage amplitude should be always greater than whichever is the highest threshold voltage. the magnet, assume that here it is 3.68 volt and here it is minus 1.5, the input voltage should be more than 3.68. Maybe in the last case, if it is minus 0.36 and minus 2.92, the input voltage should be greater than 2.92 magnitude. So always the input voltage should be greater than the greatest amplitude of VTH and VTL. So let me write that V in amplitude or peak should be greater than maximum of VTH magnitude and VTL magnitude. So if it is like, okay, if it is 2 and 1, then input should be more than 2 volt. If it is like, okay, 1 and 3, then input should be more than 3. I'm just writing the magnitude. It can be minus 1 and minus 3. So what is the magnitude of this? It's 1 volt. Its magnitude of minus 3 is 3 volt. So in such case, input should be more than 3 volt. If it is less than 3 volt, then it will not make a transition from plus to minus or minus to plus. It will be there in one of the condition. So let me just demonstrate that. See now, you're getting the transition. Suppose if I reduce this amplitude to 2 volts, it's coming because the threshold voltage, how much is the threshold voltage you have? Of course, we have just randomly varied. So let me make this. See now, suppose if I make this, can you see output has gone to this plus side? It is not at all making a transition because you apply a lesser amplitude. If I apply a larger amplitude, then the transition, because your input will be crossing the threshold voltage, then it will come. So that's why in this particular Schmitt trigger experiment, input amplitude should be always greater than the magnitude of maximum of VTH and VTL. It should be absolute value maximum of VTH or VTL. So this is an important thing. Even if everything is fine, suppose if you have simply applied lesser amplitude, you will not get it. You will not get the output because it is not crossing that, your input is not crossing the threshold. So when your input is not crossing the threshold, output cannot switch from plus V side to minus V side. It's a simple common sense concept. Thank you.